That's what happens. So this is all warm up so that we can tackle word problems. Okay. So page 35, same method as before, just more work. All right. Be careful when selecting POIs. It has to surround the solution region, right? So that's important there. It has to surround the solution region. Some students just find all the intersections they can possibly find. Just give me all those points. And it's like, well, I need to know which ones are the POIs. It is a good idea to graph all lines on the calculator before graphing it on paper, since the POIs might be outside the grid. Okay. Graph all lines on the calculator before graphing it on paper. And you know what? 90% of the time you're going to be able to get away without doing that, but sometimes you do run into that problem where the POI is outside the grid. So you need to select a scale to make it all appear on your graph. So here it is, 3 inequalities. Most of the time I'll be nice and just give them like this. I'll spread them out already so you can do the work right underneath. If I don't, just call them 1, 2, 3, right? And then do the work all around the paper wherever you find a spot. Okay, let's start. I will rewrite them all, or at least in the format that I would like to start off. Find the intercepts, and then go and basically graph them just like before. So watch this. I don't like this format, so I'm going to just do a slight change. I'm going to bring the 4y over to the other side. It's going to come over subtracting. Nothing else changes. The symbol stays the same. Sorry. So I'm kind of conservative with my spacing because I need room for the rest. So I'm going to find the intercepts. And some students have asked in the past, why can't I just graph it on the calculator? And this is like a fail-safe. It's like an extra step that allows you to determine whether or not you made a mistake. So I take this one, and it's basically 3x is equal to negative 12. Let me focus a little bit more, it feels like. 3x. So divide both sides by 3. X is equal to negative 4. That means that the intercept is negative 4, 0. Y-intercept. Negative 4y is equal to negative 12. Divide both sides by negative 4. Y is equal to negative 12 divided by negative 4 is 3 positive. So it's 0, 3. Let me do something here. I'll zoom in just to that area for now because I feel like this might hurt your eyes a bit too much. So basically, I don't want you to even really think much about it anymore. When I ask you to graph, find the intercepts. But before you do this, clean this up. Clean up whatever is up here. If there are brackets, like terms, bring them all over, clean it up so that it looks like this. Okay? Let's rewrite this one in y equals mx plus b format. I'm going to rewrite the thing just because this is the one example where we need to make sure our notes are detailed. I'm going to bring the 3x over to the other side. So you end up with negative 4y less than negative 3x minus 12. And what happens here should ring a bit of an alarm, right? You're dividing by negative 4. So when it's negative, in the notes, I'll try to give it some kind of color there. So y, flip the sign, right? Let me use a blue pen for that. And then negative and negative, that's 3/4 x plus 3. Flip sign. Perfect. I'm going to take that, I'm going to meet it. And quickly, I'm going to note it's dashed. The true region is above, right? Above the line. And this is a system I'm going to shade below. Reverse shading. That's why I shade the opposite of where the true region is. Okay. If they're both arrows would have been pointing the same way, I'm using regular. I want to use reverse. Okay. So this one, I don't think there was a lot of surprises there. Didn't have a lot of hiccups, but the next one will. So pay attention to the next one, okay? It does show up even in the word problems. There's not really a whole lot to it, but I'm going back up to this one here. I'm zoomed in, so sorry if you can't see the whole thing. I want to say this. You should notice that there's no constant here. There's no number on its own. Okay, so I'll make a note here. No constant. And yesterday you had, like if you did the homework, there's a question there where it's y, x. So all you had was y and x, right? No constant, same idea. Okay. This goes, right? That means that it goes through origin. This will go through the origin, guaranteed. It doesn't matter how big the numbers are in front of x and y. If there's no constant, it goes through the origin. So watch this. Let's make it look like this one here. So I'll bring the 3x over. So it ends up positive 3x plus 4y. And what's left on the right side? It's going to be 0. It's going to be 0. So if you find the x-intercept and the y-intercept, you're going to get 0, 0 for both of them. That's going to be 3x is equal to 0. Divide them both by 3, x is equal to 0. So 0, 0 is our x-intercept. And you're going to find that 4y is equal to 0, same thing. So what is happening here? It doesn't help me at all. Like 0, 0 connecting to 0, 0 doesn't give you a line, does it? So it's a problem here. I'm going to highlight that or circle whatever the no constant up here. Okay, this part. So this is how I circumvent this issue. We're going to go back to this one. 4y is less than or equal to negative 3x. So you're basically going to rewrite it. So we divide both sides by 4. Y is less than negative 3 over 4x. And this is the part where you need to pay attention. X is the independent variable here. Okay, I will let it be something. I will say, hey, I will let X be something, and then we'll figure out the Y. So let X be, you can let it be anything you want. Okay, but there's something, you want to be strategic. I'm going to let X, this number here, be 4 in this case. Let X be 4. Because what happens then? Y is less than negative 3 over 4 times 4. Right? I'm plugging 4 there, which cancels. Okay. Oh, sorry. For this step, you don't want the inequality there because I'm still dealing with just the line at this point. So what's y equal to? If 4 and 4 cancels, you're left with just negative 3. So when x is equal to 4, y is equal to negative 3. That's what you just found there. So we're going to say the second point is 4, negative 3. It's the second point. And I'm going to do my highlighter part here. I'm just going to say we let x be 4, and therefore that is the x value of that second point we're after. I used to have a green highlighter, a nicer one. Okay. Anyways, and y is equal to negative 3, and that comes here. And so this, I'm going to circle this because this is very important to get that second point. We used to be able to get our 2 points here, but now we had to add this extra step here, okay, to make this happen. So I'll just go extra step. Mr. Dixon, could I have made x equal to 10? Yeah, then it would have been 3 times 10 is 30 divided by 4. That gives you a decimal, right? Could have could x have been 9 maybe, right? 9 times 3 is 27. Yeah, but it doesn't, this is just cleaner, that's all. That's why I picked 4. I picked 4 strategically because of this denominator here. If this had been 100, then I would have let x be 100 so that these would have canceled out nicely. Okay, okay, let's graph. We're not quite ready to graph. We have to deal with that last one. This one is easy, by the way. You should know, right? This is a vertical boundary. Vertical boundary goes through -4, 0. Okay. We know that this is going to be a solid, and the true region is, it's already isolated, so true is to the right. We are going to shade the opposite. And I didn't do that with this one. Let's circle this part here. This was actually important. This was the rewritten form. Go back to this one. And we're just going to do it right beside it. Dashed. True is below. Shade above. And for me, okay, there. For me, these are very, very important. In fact, when I mark yours, and this is going to be a nightmare tomorrow, this test. Out of all tests, I dread this the most. Okay? Because if you make any mistakes here along the way, your graph is going to look completely different. So that's just part of, but by the time you get to the end, you're actually pretty good at doing these. So let's graph these all on our calculator first. Before we do anything, we grab our calculator, and I'm also gonna reveal how to do a vertical line. Did I show you that already in quadratics? How to do a vertical? I don't think so. So let's type this one in first. Brackets 3/4 x plus 3. The next one is negative 3/4 x. That's it. How would you do a vertical on this calculator? I found this on YouTube because for years I didn't know how to do it. But I just looked it up. Some students were wondering there must be a way. Here it is, guys. If you want to graph the line, right? So what do I have here in my notes? To graph vertical, you got to go y3, and don't ask me why, but you have to put in 9 nines. 1, 2, 3, 1, 2, 3, 1, 2, 3. You want to graph x minus 4, right? So you have to enter, it should give you flashbacks of the quadratic. You have to enter x plus 4, the exact opposite of what you see. Okay, so I'll make an arrow, opposite sign. Okay, opposite sign of what you want. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, like 9 nines, bracket, x plus 4. And let's graph this. X plus 4, not minus 4. Okay. There's that vertical line. I don't know how that works, but it works. Let's try zoom 6. Zoom 6 is a 10 by 10 window. There it is. That's probably a little better. We don't know where our solution region is, right, guys? We don't know. It could be anywhere. Could be anywhere. So we have to figure that out now. The calculator won't do that for you. But now we know. Like, look at this, guys. This is a 10 by 10 by 10, right? So a 10 window will work just fine. So let's go and graph this. Y and x, x and y, one at a time. So negative 4, 0, 3. 1, 2, negative 4, 0, 3. If your scale is anything but 1, you need to make sure you label your axes accordingly. Okay? I'm told that's a dashed line. There you go. Label it out here. My second line, it's 0, 0 and 0, 0, right? But it doesn't help me. So I'm going to use this point that I found, 4, negative 3. So I'm going to go 1, 2, 3, 4, negative 3. Question, Mr. Erickson? Yeah, go ahead. The slope is negative 3/4. Could I have started with the intercept here and then went 1, 2, 3 over 4? Yeah, you could have done that as well. But sometimes these numbers are going to be big, like 30, 50 or something, where it's going to be harder to do that on the grid. Okay, so maybe just trust me for now. So we graph our line, it's solid. No, it's dashed. Oh, almost solid. Almost went for solid, but that's an easy fix. You just erase, right? And I'm going to label this y is less than -3/4x. And the x minus 4, right? It's like 1, 2, 3, 4. It goes right through here, and it's a solid line. It's a solid line. Which is x is greater than or equal to -4. Now we're going to have to find our solution region. We're going to use reverse shading. So we're going to go back to the first one, which is this one. It's pointing up. And we're told to shade where? It says right here, shade below. Right here. So I'm going to shade below it. All of it. Everything below that line is false. Basically, you're ruling that out. It can't be. You got that? Next one, it's this line here. I'm just going to focus on it, and I'm told that I'm going to shade above it. So no problem. I line it up, and I shade everything above that line. And you will see that overlap, right? And you're going to also be shading off more. You're going to be shading off this area that hasn't been until now. So everything above that line is also gone. Can't be used. Not a solution. And the last one, this one we're told we shade to the left. Hold it, right? Let's stop there for now. Right now, my solution region is this, right? But because of this, we're going to shade to the right and rule that out as well. So this line comes along. And you determine that in this case, there's a tiny little sliver, a triangle in this case, that is the solution region. So you go in there and just write solution like that. Okay, that's it. So now we look at what are lines, these lines, there are 3 lines that make that region. So we need to find the POIs, right? These 3 points surrounding your solution region. Okay, so let's go ahead and find them. Mr. Erickson, is it always going to be a triangle? No, it's not always going to be a triangle. I wish I could have the undo button here, but let's say, for instance, we had shaded to the right of this vertical, like everything to the right of it. Your solution region would have actually been this here, this section right here, okay? So it changes based on what you're shading, right? So POIs, let's find that. I'm going to grab my calculator. I'm going to go back to the graph, and now I'm determining that it's this section in there, this triangle that is the solution region. So I do have 3 corner points around it. So I go second, trace 5, and sure, I'm going to start with the blue one. I'm going to hit enter, and then it jumps to the red one, which means you're going to find this one here. Just keep hitting enter. So that's -2, 1.5. and then go along the blue one. Oh no, actually I gotta go second trace again, sorry. Second trace 5 and travel along the blue one in this case, right? Closer to that one, I hit enter. You don't want the red one, so I go arrow up and arrow up again. Now I'm on the black line here. So you can go sideways. Sorry. You can't see a cursor on it. I don't think so. Or no. So that's okay, but you are on this line. So just hit enter, enter, and then it finds that one there, which is -40. We expected that to happen. And then second trace 5 one more time. Jump to the red line. I'm going to jump to the red line and go as close as possible to this one that I'm interested there. Hit enter. It automatically jumped to Y3, which is the vertical. So you want the intersection between those two. Enter, enter. So that's -4,3. No surprises that it's -4, right? Because it's along the x is equal to -4 line. Okay. So those are the POIs there. Let's say this is you're like, I can't handle 3 lines, right? Just go ahead, turn off one of them, right? And just find the one intersection, then turn on the other 2 you're interested in, and so forth. Just loop through it like that. I'm done after this, guys. Is -3,1 a solution to the system? Show your work. So this is what we're going to do. I'm going to go back to the original. Let me just zoom out a little bit. And I'm going to plug in -3. So 3 times -3 less than 4 times 1. I'm plugging in that point, -12. This is -9. And on the other side, you have 4 minus 12, which is -8. Is that statement true? The answer is yes. Yeah, so true. Keep going. You got to keep going. I'm going to grab the other one. 4y is less than -3x. So 4y, be very careful, 4 times 1 is less than -3 times -3. So that's 4 is less than -3 times -3 is 9. This is also true. Last but not least, x is greater than or equal to -4. Let's plug in x, right? X is -3. Let's plug that in here. Is -3 greater than or equal to -4? This is also true. Therefore, -3,1 is a solution to the system. If even one of them had failed, had been false, you can actually stop. Don't keep checking because it's not it anymore. Like, it has to be true for all 3 of them. Okay, how about this? Let's go to 36. I'm just going to give you one to try. And I'll give you a little bit of class time tomorrow to try another one in class. So go to 36. I just want you to do page 36. This is your homework. If you want to venture out and do more, go for it. Go for it. I just want to mention this. So this is page 36, right? You will notice that all the grids have the answer at the bottom here, the POIs. They're upside down, right? So you can't tell right away. But those are the points that are around the solution region. So it tells you that you do your shading right. It might be that your lines are right, but your shading might not be right. So try at least one. I know it takes time, but it's important for you to try.